Once upon a time, there was a man named Galileo Galilei. Galileo was an intelligent man. He is known as the father of modern physics. He had contributed a lot in the field of science, but those are entirely different discussions. What we are going to talk about are his contributions in the field of modern physics. According to a biography made by one of his trusted assistants, Galileo had dropped balls of different masses but the same material from the height of the famous Leaning Tower of Pisa. He wanted to prove that their time of descent was independent of their mass. Galileo proposed that a body will fall with a uniform acceleration given the body is not subject to any opposing forces like air resistance, or in other words, if it is falling through a vacuum. Isaac Newton. Isaac Newton is the father of calculus together with Gottfried Leibniz, and he is also known as the father of classical mechanics. Like Galileo, he held a major role in the scientific revolution. His book Mathematical Principles of Natural Philosophy, or more commonly known as Principia, published in 1687, had laid foundations of classical mechanics. In his work, The Principia, he explained the three universal laws of motion. These laws, which Isaac established, have changed the depth of our knowledge and understanding in physics today. The three laws are inertia, acceleration, and interaction. Let's tackle the first law of motion. The law of inertia states that an object continues in its state of rest or uniform motion unless compelled to change that state by an external force. Let's define the terms that might be new to you. Inertia. This is the resistance of any physical object to any change in its state of motion. State of rest. This state of motion means the forces acting upon an object are balanced, thus canceling out each other, having a net force of zero, causing the object to be stationary. State of uniform motion. This state of motion means an object is moving in a straight line at constant speed. External force. An external force is any unbalanced force exerted on an object. Look at this stationary ball. It shall continue in its state of rest until there you go, until an external force acts upon it. Now, look at this rolling ball. It will be put to rest once it reaches that box, the box being an external force exerting a push to put the ball to a stop. Now, let's proceed to the second law. The law of acceleration states that if a net force acts upon an object, it causes an acceleration of that object. It addresses the relationship between acceleration and force, and between acceleration and mass. Acceleration is directly proportional to the force exerted on an object. Let's imagine a box. The greater the force exerted on the box, the greater acceleration it will cause. The lesser the force exerted on the box, the lesser acceleration it will cause. Acceleration is inversely proportional to the object's mass. This time, let's imagine two boxes, one heavier and one lighter. Let's say both boxes were pushed with an equal amount of force. The heavier box will be harder to move compared to the lighter box. Why? This is because the heavier the box, the lesser acceleration a force will cause compared to the acceleration it might cause to a lighter box with less mass. Last but not the least, the third law. The law of interaction states that for every action there is an equal and opposite reaction. Try pushing on a wall. Does the wall move? If yes, wow, are you sure it's a ball? But if it doesn't move, well, there you have it. The force you exert on the brick wall is countered by the force exerted to you by the brick wall. Yes, the wall is exerting a force even though it is stationary. Now these are the three laws of motion: the law of inertia, the law of acceleration, and the law of interaction. These laws have helped us understand the mechanism of physical motion of all matter, and we owe it all to Galileo and Isaac.
Created using Powtoon.